All right, okay, students, can you all hear me? Can you all hear me? All right, okay. Right, okay. Let's start now. So, first of all, good evening for all of you. Subbalutaruddakpeva, right? So, first of all, wish you a happy new year. And I think 2025 will be your year, right? So, I guess that this is your examination here. So, I believe that this will be a very successful year for you all. Huh? So then let's start. So January 1st, we are starting with 25 batch, right? So therefore, that's a good thing. So, right, okay, students, as we discuss, we have to do organic chemistry, reaction practice sessions. I told you that. So these are free sessions actually. Other students also can attend for this one. So I can see that on many students have joined for the WhatsApp group also. So remember, so now we have completed unit number 7, the basic concepts of organic chemistry. In the last theory session, we started hydrocarbons and halohydrocarbons. Parallel to that one, we are going to discuss these organic reactions. Okay. So before we go for the organic essay questions, structure essay questions, and essay questions, we have to practice organic reactions, right? So I told you that to bring a 200 pages CR book with you, right? If you don't have CR book with you today, it doesn't matter. So you can copy down everything that I'm going to discuss today here in a notebook, and later you can take a CR book, 200 pages, and copy down everything, because we are going to do lot of reactions, right? We are going to do a lot of reactions. We don't know how many we are going to do, but we have discussed many reactions until you satisfied with I can do organic conversion, I can do organic reactions, I can remember organic reactions. Until that one, you have to do. Okay, right. So let's quickly go for the topic. Students, already we discussed about what is organic chemistry. You know the basic stuffs, and you know how to identify the organic compounds, the type of organic compounds. What is the contribution for the examination from organic chemistry, right? So we already discussed about these things in our theory class, right? So we know that we can collect about 20 or more than 20 marks from only from organic chemistry for your examination. So therefore, we have to be very careful. We have to do a lot of questions. We have to do a lot of practice sessions in order to get collect those 20 marks, right? So today we are going to discuss organic chemistry reactions. But before we go for that one, let's try to identify what are the question types you will get for the organic chemistry questions in the examination, right? I'm going to discuss here what is the importance of organic reactions, what is the importance of learning organic reactions, right? When you consider our A-level examination paper, remember students, organic chemistry actually, I told you that more than 20 marks, right? So this more than 20 marks means this is very important for you, right? If someone can do only organic chemistry, he can just get S pass if he do only organic chemistry. So that much important. So when we consider the question types that you will get from the organic chemistry, the first question type is actually, we can say that nomenclature. We discuss about the nomenclature in the theory class under the number 7. We discussed the past paper questions also. So I told you that how nomenclature is easy. That's very easy, right? Only one MCQ, probably the fifth MCQ. This year paper also, the fifth MCQ is given by nomenclature, right? So the second type is actually when you go for the structured essay paper, isomers, right? So when we hear, many students are when hearing this isomer topic, shivering. Why? Isomer topic is actually very hard. So that is the thing. That is the way that students are thinking. That's not like that. Students isomers are easy, but we need a lot of practice, right? Parallelly with the organic reactions, I'll do some isomer sessions also. I plan to discuss 2011 to 2023 A-level isomer questions with you, structured essay questions with you. I will upload all the session here in this group. Anyone can access for those questions also, right? Isomers past papers. Doesn't matter. I'll inform that one. So this is the second type, right? And we know that 5 marks carried by isomers because structured essay question. The fourth structured essay question in your examination paper is isomers. So therefore, you can't ignore isomers definitely. So that's a compulsory question you have to do. So therefore, the second question type that you will have is isomers. And remember, students, we have some other questions from identification test, right? There are some identification tests. For an example, Sillo mirror test, then Brady region, Fairing region, identification of terminal alkynes, identification of unsaturation. So likewise, there are many identification tests we have to discuss. So let's discuss those things also later, along parallel with the reactions. So these are the third type. And then with that one, we have about the bonds. What are the bond types that we have in organic chemistry? And then we have reaction mechanisms, right? Reaction mechanisms. This is also very important. For an example, Fiedel-Kraft acylation, alkylation, nitration, addition of HBr to alkene, addition of Br to alkene, right? So likewise, there are so many reaction mechanisms that they are frequently asked, right? When we discuss about the alkane, the first reaction mechanism we are learning is addition of halogen, addition of chlorine or bromine to alkane, methane, CH4. So that is the first reaction mechanism you are learning, and it is very difficult. Okay, so therefore difficult to remember. So likewise, there are reaction mechanisms, right? And the last type is what? Conversions. Most of the students are thinking that organic chemistry is equal to what? Conversions. It's not like that, right? So when you consider the last 5-year organic chemistry questions, they are balanced, they are perfectly balanced. These conversions are not that much difficult. You analyze past papers from 2011 to 2023, when you analyze the past paper students, after 2019, organic conversions are not that much hard. All of them are easy. ඒව එච්චර අමාරු නෑ. ඒව සාමාන්‍යයෙන් කරගන්න පුළුවන්. ඒ කියන්නේ 2019 ඉඳලා 23 වෙනකන් සෙට් එක ඒව අමාරු නෑ. Anyone can do that. But before 2019, actually the questions were hard, a bit hard. So in order to do organic conversion, you have to know all the organic reactions, right? So we can tell that instead of taking the organic reactions, actually we are going to discuss about the conversions, right? My main concern is about this topic, conversions. The reason that I didn't put here organic conversions, because in order to do these questions, you need to have the knowledge of organic reactions for each and every topic, right? In order to do isomer question also, you need some kind of what? Reaction knowledge. In order to do identification test question also, you need to have some kind of a reaction knowledge. In order to identify the bonds also, you need to have a reaction knowledge. Reaction mechanism also like that. But it is mainly contributed for the organic conversions. Right? Remember, students, I can remember that when I'm doing element, so we did organic conversions, many organic conversions. Some of the students are doing 1,000 of organic conversions, 500 of organic questions, many organic conversions. But the quantity is not that much important, right? It doesn't matter how many conversions we are doing, how many organic reactions we are practicing. The thing is how much you gain, how much you can apply for the examination period. That is what the most important thing. So therefore, I'm going to discuss all the organic reactions with you here. What are the organic reactions we have in our syllabus, unit number 7, 8, 9, 10. Let's see how to do these questions using those reactions. Okay. So try to understand these are the question types that you will get from the organic chemistry in the examination. Nomenclature questions, isomers questions, identification test, bond types, reaction mechanisms, and the conversions. Right? In order to do these questions, we need to have the organic reaction, organic chemistry reactions. Right? Write down these things quickly in your writing book. Now let's move to the organic chemistry reactions. Organic chemistry reactions. Write on the topic quickly. Remember, students, when we discuss about the reactions in organic chemistry, there are 4 types of reactions, right? Remember, there are 4 types of reactions in organic chemistry. Number 1, the first type that we are going to discuss is carbon atoms increasing reactions. Carbon atoms increasing reactions. The second type of reactions that we are going to discuss is special conversion reactions. Special conversion reactions. Okay. And the third type that we are going to discuss is carbon atoms decreasing reactions. Remember, students, carbon atoms decrease in reactions also there, right? Decrease in reactions. And the fourth type is reactions related to the identification test. Reactions related to identification test. There are so many identification tests, but we are going to discuss only few reactions related to this identification test. Right? So remember, students, we are going to discuss about more than 60 reactions. We can categorize all of these reactions under these 4 topics. Carbon atoms increasing reactions, special conversion reactions, carbon atoms decreasing reactions, and the reactions related to the identification test. So these are the 4 types. Right? So we can consider that when we consider the carbon atoms increase in reactions, so there are about 30 reactions. We can say that less than 30, right? Less than 30 reactions are there. When we consider the special conversion reactions actually, so this is less than 20. Special conversion reactions are less than 30. Okay. Carbon atoms decrease in reactions are less than 10 wage. And when we consider identification test, we have about 3 reactions. Now you can take the summation. So as I said you, here we have 63. Ne? Remember, students, definitely you will have about 60 reactions. That means more than 50 reactions for your A-level syllabus. Now just imagine how we can remember this much of reactions before we go for the examination. Reactions, more than 50 reactions, right? So that's why I told you that organic chemistry is actually very interesting, but it's very tricky. In order to collect these 2022 marks, you have to practice a lot, right? Just imagine how we can remember these reactions in one night. Can we do that? You can remember them, doesn't matter. Within 3 days, you can remember that one. But when you go for a question, you don't know how to apply that. So in order to apply for the questions, you need to do the practice. So that's what I'm expecting to discuss here with you, these organic reactions, right? Carbon atoms increase in reactions, special conversion reactions, carbon atoms decrease in reactions, reactions related to the identification text. ඔක්කොම එකතු කරාම 60ක් වගේ තියෙනවා. Anyway, there are more than 50 reactions. Can you understand? Quickly write down. And we are going to start one by one. Carbon atoms increase in reactions 1, special conversion reactions number 1. Likewise, we are going to discuss one by one. Write down these things in your writing book. Quickly. Done, right? Okay, then write down the subtopic. Carbon atoms increase in reactions number 1. Carbon atoms increase in reactions number 1. Carbon atoms increasing reactions number 1. Aldehydes and ketones. Aldehydes and ketones with Grignard region. With Grignard region. With Grignard region. Students, we discuss about what are the aldehydes and ketones, how we can identify aldehydes and ketones, and we know what does mean by Grignard region as well, right? Students, if you have any doubts, please put your doubts in the chat box. I will answer for your doubts, okay? If you have any doubts, put your doubts in the chat box. So aldehyde and ketones with Grignard region. Yes, you have to write down everything in a separate book. Okay, I told you in the theory class, take a 200 pages CR book. We are going to do that much of reactions. So write down these things in a separate book. Okay. Can you understand? Yes, recordings will be shared. Recordings will be shared, but I recommend you to attend for the live sessions. That's worth attending, right? For the live sessions. Right. Okay. Look at the topic: aldehyde and ketones with Grignard region. Remember, students, aldehyde and ketone, how we can identify aldehyde and ketones? We know that aldehyde is containing C double bond O H group and ketone is containing C double bond O carbonyl group, right? So therefore, try to understand when I consider an aldehyde like this or ketone, right? If you consider only hydrogen here, then that is an aldehyde. If you consider here R group again, it is considered as what? It is considered as a ketone, right? So you know the difference between aldehyde and ketone. So then we are going to add the Grignard region for this aldehyde and ketone. Listen to this one very carefully. Yeah? First of all, I'm going to explain you what is the reaction, how it happens, right? So later you can consider this one as what? The reaction mechanism. But try to understand. Here, I'm going to explain what will happen. Then you can answer for the questions that they have given. You can easily get the products of the reactions easily. Yeah? So therefore, first of all, listen to this one very carefully. Yeah? Everyone, listen to this one very carefully. Students, I'm going to add the Grignard region like, just imagine I'm going to add R dash MgX. You know that R means alkyl groups. Ne? Alkyl group means we can say CH3, CH2, CH3, methyl, ethyl, propyl wage alkyl groups. So what does mean by a Grignard region? I think probably you have Others, you have learned those things in your classes as well, lighting in your school also. So the Grignard region means when we add magnesium, right, for alkyl halide, we can obtain a Grignard region, CH3MgCl, right? So the Grignard region means alkyl magnesium halide, right? So Grignard region is always alkyl magnesium halide, CH3MgCl, CH3CH2MgBr, right? Otherwise, you can consider CH3CH3. So likewise, we have alkyl group connected to MgBr, MgCl. So that is known as a Grignard region. So students, we are going to discuss about aldehyde and ketones are reacting with the Grignard region. Remember, this reaction is very, very important. I would say this is the most important reactions in your organic reactions. Right? This is one of the very, very important reactions we have to discuss. Can you understand? So therefore, try to understand. We are adding Grignard region for this aldehyde and ketone. Now look at this one. Make students, you know that in aldehyde or ketone, we have a carbonyl group, right? So this is known as carbonyl group. See, double bond is known as carbonyl group. And the carbon-oxygen group, carbon-oxygen bond is polarized. We know that between carbon and oxygen, there is electronegative difference. Oxygen is the most electronegative atom. So therefore, what will happen? Oxygen is pulling electrons from carbon, right? Carbon-oxygen bond is polarized. Oxygen is pulling electrons from carbon. So therefore, oxygen is delta minus, negatively charged. Then what will happen to carbon? Carbon is delta plus, positively charged. Can you understand? Because of the polarization of this carbonyl group, carbon-oxygen bond, oxygen is pulling electron, oxygen is negatively charged, and carbon is positively charged. Now look at the Grignard region you have added. Look at the Grignard region. Remember, students, when we consider the Grignard region is also polarized. Why? In the Grignard region, you can see that R dash means alkyl group. It can make a CH3 when the on CH3, CH2, and some kind of a bulky alkyl group. It is connected to magnesium halide. Remember, magnesium is somewhat positive. Compared to this alkyl group, magnesium is a metal, alkaline earth metal. So therefore, that is positive. And R dash group is becoming negative. Right? There will be a small charges between, there will be a small polarization between these two groups. Then magnesium is positively charged and this is negatively charged. Then we can say that R group is taking electrons from this bond. Can you remember in the last session, in the last theory session, we learned heterolytic cleavage and homolytic cleavage. Right? There are two types of covalent bond cleavage. In your resource book, they have given there are two types of bond cleavage. So tell me, students, what kind of a cleavage is this? What kind of cleavage is this? Homolytic or heterolytic cleavage? Quickly. Put your answer in the chat box. Yes. Yes. This is heterolytic cleavage, because these two electrons are taken by alkyl group. If we consider one group is taking one electron and the other group is taking the remaining electron, then it is known as homolytic cleavage. So therefore, this is heterolytic cleavage. This bond is broken because of this polarization. Now you can see that R dash is taking electrons and it's going towards this carbon atom. Why? Now R dash is negatively charged. This is delta minus. This delta minus should be connected to which pole? Positive pole or negative pole? This is delta minus. Then definitely this one should be connected to carbon atom, which is positively charged. Remember, students, I want to tell you something like this. When you are writing the reaction mechanisms, always the examiners are checking these arrows. How you put these arrows? These arrows are very, very important. මේ arrows වලට තමයි ලකුණු දෙන්නේ. මේකට දෙකයි ගාලා ඊළඟට මේ poles වලට ලකුණු දෙනවා. If you have put delta minus and delta plus also, they will give marks. Right? So someone can consider this is the reaction mechanism we are going to learn. Right? I will discuss reaction mechanisms separately, but I want to explain you what happens inside accurately. You want to know that one. Right? That's why I'm teaching here this one. Okay? Otherwise, we have a short method. I'll discuss that one later. Right. Okay. Now try to understand. R dash is negatively charged. So this bond is polarized. R dash is taking electrons from this bond and leaving, connecting to the carbon atom. Then students, you know that when R dash is connecting to this carbon atom, carbon is forming 5 bonds. Neither. 1, 2, 3, 4. R dash is also connecting here. Can carbon form 5 bonds? No. Carbon cannot exceed the octet. Carbon can make maximum 4 bonds. It can keep maximum 8 electrons. So then what will happen? Remember, this bond is breaking. That means a double bond will break. Then oxygen is taking electron and this bond is breaking. Then students, you have to write down the correct product here. Look at this one. Look at the way that I'm going to write down the product here. R, C, O. Now oxygen is taking electrons, right? Oxygen has taken electrons. So therefore oxygen is negatively charged. Right? We know we don't have to mention the lone pairs, but try to understand me. If there are 2 lone pairs and this bond is broken and 2 electrons are taken, then we can put 3 lone pairs. Therefore oxygen is negatively charged. Easy, easy Lewis structures. Then here HOR, aldehyde or ketone group. And remember, R group, alkyl group in the Grignard region now connected to the carbon atom in this way. So therefore we can consider carbon is connected to R dash. Look at the product, right? Now in the examination, you are asked to write down what is the product, what is the first product that you will obtain when we add Grignard region for the aldehyde and ketone, right? If you have learned this reaction, sometimes you know that students, actually the final product of this reaction is ROH, HR, R dash. This is alcohol. Those who have learned this one previously, you know that students, the product is an alcohol. This is actually one of the way that we can convert aldehyde ketones into alcohol using the Grignard region, right? But when you ask to write down the product obtained when we add Grignard region, some of the students are writing this one. No, this is not the initial product. This is the final product. Actually, in this reaction, we have an intermediate like this. This is an intermediate, right? Try to understand. Then students, you can see that MgX is like this. MgX positively charged in this way. This is the first step of the reaction. Remember, the second step that we are going to do here is we are going to do the hydrolysis reaction. Right? What we are going to do here, we are going to do the hydrolysis reaction. Hydrolysis means, plus we are going to add here H plus slash H2O, right? Acidic water, or else we can just write down by connecting these two, we can write down H3O plus. Both are correct. H plus water, or else we can put what? H3O plus. Both are correct. That means this product, the first product that we obtain, is gonna react with water molecule. With a water molecule. The product that we obtain is going to react with a water molecule. Look at the reaction. R CO minus, oxygen is negatively charged, and this is the alkyl group which came from the Grignard region, and we have a water molecule like this, H2O. Students, remember, now this is a hydrolysis reaction. Hydrolysis means the reaction with water. In water molecule also, we know that OH, oxygen hydrogen bond is polarized. Oxygen is negatively charged, delta minus. Hydrogen is positively charged, delta plus. Oxygen is taking electrons from hydrogen. Now hydrogen doesn't have electrons. Hydrogen has to leave from the water molecule. Hari, මෙයාගෙන් electron ඇදලා එළියට දානවා. යන්න ඔයා. Right? Oxygen is taking electrons from hydrogen, and hydrogen has to leave from this compound. Then what will happen? That hydrogen is taken by this oxygen atom, because this is positively charged, right? Can you understand? Because of this bond polarization, oxygen is pulling electrons. Therefore, oxygen can take the electrons from this bond. then hydrogen has to leave as H plus. Hydrogen is positively charged. That H plus is taken by this oxygen. Then students, you can see that the final product of this reaction is RCHR. And here we have R dash group, which came from Grignard region that we have added. And here we have OH. Tell me, what is the product? What is the type of organic compound that we learn? Alcohol. Remember, students, this is an alcohol, right? We have started from aldehyde or ketone. We have added Grignard region for that one, and we ended up with alcohol. We have started from aldehyde or ketone, added Grignard region, and secondly, we are doing the hydrolysis, right? Let me write down, this is number 1 and this is number 2, because these are 2 steps, right? When you are doing the conversions, you have to write down number 1 and number 2. Can you understand? So therefore, here we can say that this kind of alcohol is produced, right? Sir, then what will happen to this Mgx plus and what will happen to this OH minus? Now hydrogen left this water molecule as H plus. That H plus was taken by oxygen atom. Then remaining OH minus is there. Then that remaining OH minus is connecting with this Mgx and producing a byproduct like this Mgx OH. This is the byproduct of the reaction. You have to remember this story. This is a story. Explain right? You have to remember this story, right? Now I told you that one. So likewise, you also should be able to tell like that. We have an aldehyde ketone. We are adding Grignard region. In aldehyde ketone, carbonyl group is polarized. Oxygen delta minus, carbon delta plus. R group is negatively charged. Mgx is positively charged. Bond is breaking. R is taking electrons, and that R is taken by carbon atom in the aldehyde and ketone. And we have an intermediate like this. We have an intermediate like this. Can you understand? We have an intermediate like this. One more thing I want to tell you. I want to tell you that one. Now we have O minus and Mgx here. We have O minus and Mgx. So won't there be any reaction between these two? Won't there be any reaction between these two? Yes. Students, there will be a reaction. We can write down, instead of writing in this way, we can write down OMgx. We can write down in this way, right? So if you ask to write down the first product of the reaction, this is the product that you have to write down, right? So then only we are coming to this step, right? That means we can tell that exactly RCOMgx, and here we have R dash. We are adding water molecule. We are adding water molecule means H and OH. Okay, look at this one. OH group is connecting to Mgx. This hydrogen is connecting to oxygen. That's what I have mentioned here, right? So where is the Mgx? Where is the Mgx bond? So this is an ionic bond. So therefore, you can write down this compound, this product, without mentioning the Mgx also. It doesn't matter. So therefore, we can say that OH is leaving with Mgx, and then hydrogen is connecting to oxygen. Then we have the product as an alcohol, right? So this is actually not the part of the reaction mechanism. This is the part of the reaction mechanism, but you have to remember this one also, right? OH is connecting to Mgx. That is the byproduct, right? Can you understand? So what are the doubts you have? First of all, raise your hand who understood the things that we discussed now here. Quickly raise your hand who understood the thing. And if you have any doubts, put your doubts in the chat box. Yes. Isala, I will provide you the details. Huh? Yeah, Grignard region means, as I told you, Grignard region means Amani uh, alkyl magnesium halide, right? That means alkyl halide is reacting with magnesium brighter and forming alkyl magnesium halide, right? Yeah, so we have a very good question. So in some questions, they sometimes state only H2O. So is it fine if you also only write H2O without writing H plus H2O? Remember, actually this reaction should take place in acidic medium. What does mean by H plus? H plus means simply we can tell that an acid. So therefore, you have to check whether have they given some kind of a acid, diluted acid or considered acid. Then you write that one along with water. That means you can write down diluted acid, for an example, diluted sulfuric and water. If they have given considered sulfuric, then also you can write down considered sulfuric water. Just imagine they haven't given anything, any acid, they have just given water. Then you have to use water. But students actually they won't give like that. So you have to remember that always they will give this one. Definitely they will give you an acid and water together. You have to add them. Okay. You see the past paper questions, will you will understand them. What else we have? Yeah, Pranali, as I said you, this reaction should take place in the presence of H plus. Huh? Will it always be magnesium connected to halide in Grignard region, and why? We can consider that magnesium is connecting to the Grignard region. Actually, these are some conditions. There are some conditions to connect magnesium. The Grignard region is some kind of a region that we can prepare practically in order to increase the carbon atoms, right? Look at the topic that I have used, carbon atoms increasing reactions. So that's why we are using Grignard. Specifically, magnesium is used because magnesium is not like other elements, those group elements. It's not that much of reacting. We know that in inorganic theories, we learn that magnesium is only reacting in the presence of hot water. Okay? So therefore, somewhat less reactive compared to the group number one. Okay? Right, okay. Okay, if you have any other doubts, tell me, students. So this is the thing that happens inside the reaction. Quickly copy down this one. Use the color pens as well. No? If you have color pens, write down everything using color pens. MgXOH can be written in any way, it doesn't matter. But this is the typical way we are writing. We know that if it is an ionic compound, we have to write down the cation first. So that's why I put MgXC. Okay, don't think about those things too much. Huh? You can write down anyway. You can put OH if you want to the front. Is the arrowhead is always from negatively charged species to positive? Negatively charged to positive. We can say like this, Asuma. Electron rich area to electron poor area. Can you understand? Electron rich area to electron poor area. That is the best way to tell that. Quickly copy down. Done. Now let's take the summary. Let's take the summary. What happened? What exactly happened there? It's we added the Grignard region R MgX, right? Then we have an intermediate like this. Then we add H3O plus. So what happened? Remember, students, this bond was broken and R is taking electrons and this R connected to the carbon atom. That's what happened first of all. This R group is connected to, let me take this one as R dash, connected to this carbon atom. This bond was broken and oxygen is taking this MgX group. Then we have a product like this. R, C, what you have to do is you have to break this carbon oxygen double bond and MgX should be connected. Can you see? MgX should be connected here. And the remaining HR here. And R dash, it is connected to the carbon atom in this way. Right? Then we are adding H3O plus. We are adding H3O plus means, I told you that water molecule. Hydrogen here and OH group is here. MgX separated with this OH group and hydrogen connected to this oxygen. Then the product is, final product is R, COH, HR, R dash. This is what happened as a summary. Students, remember, these kind of reactions are known as nucleophilic addition, right? What are the reaction types, right? These are known as nucleophilic addition reactions, right? Addition reaction. Nucleophilic addition reactions. In order to tell this one, symbolize, we can symbolize this one, we can denote this one. Nucleophilic addition, AN. Nucleophilic addition. Then what is the nucleophile, right? So can you remember we learned electrophile and nucleophile? Can you remember? We learn electrophiles and nucleophiles. What does mean by an electrophile? Electrophile means we can tell that electron poor group, right? It is looking for electrons. Nucleophile means someone is rich with electrons. Those electrons can be donated, right? It will give the electrons for the others. So this is nucleophilic addition, right? This is nucleophilic addition. Then who is the nucleophile? I have a question for you. Can anyone tell me what is the nucleophile in this reaction? Anyone? I'm asking a simple question for me. Who is the nucleophile of this reaction? No, not OH minus. Yes. Alkyl group. Alkyl group came from where? Now we have so many alkyl groups. R dash is there. Alkyl group which came from the Grignard region, R dash. We can say that R dash is the nucleophile of this reaction. Students, I told you that this bond is polarized. This is delta minus and delta plus. Then this bond is broken. R dash taking electrons, that is electron rich group. That electron rich group is connecting to this positively charged carbon, which means this is nucleophile. Nucleophilic addition. Why they have named this one as addition? Addition means something is newly added to the compound. This is the compound we had. This is the compound we had initially. And this is the compound finally we got. What is the difference? Some other new things connected to, added to the previous compound we had. Here oxygen became OH. There were nothing here in here. Now we can see R dash group. That's why addition, right? We have substitution reactions also. Nucleophilic substitution reactions are also there. We are going to later discuss about those things. So therefore, this is nucleophilic addition reaction, can be denoted as AN. Take the red color pen and write down these things. Nucleophile is R dash. R dash, which came from the Grignard region. Which came from Grignard region. Quickly, Rado. Now let's consider a few example reactions with this one. Then you will understand this one more. Yes. What are the doubts you have? Yes, yes. It is must to mention MgX. Huh? Yeah. Nucleophile means electron donating groups, right? Electron donating means they are rich with electrons, so therefore they are donating electrons. Yes, you are correct. So these arrowheads is important. We can't miss any of these in exam. Yes, these arrowheads are important. When we are writing the organic reaction mechanisms, then these arrows are very important. If they ask reaction mechanisms, then these arrows are important. Quickly, Rado. Right. Now let's consider a few example reactions. Then you will understand this one more. Example number 1. We are adding the Grignard region in this CH2 MgBr. So then tell me what will happen. CH3 is taking electrons and it is connected to this carbon. Carbon oxygen double bond is breaking and oxygen is taking MgBr. Then the first product that you will obtain is CH3O MgBr H here. Now this CH3 is connected here. Okay. Then as the second step, what we are going to do is we are going to add H3O plus H plus H2. Then as we discussed, hydrogen is connecting to this oxygen and OH is eliminating with this. So therefore the main product, the major product of the reaction is CH3OH, HCH3. So the byproduct is MgBr. Can you understand? Second example with me. Don't worry, at the beginning these things can be difficult for you, but with the time, with practicing these things, everything will be normal. Huh? CH3, C double bond OH, We are adding the Grignard region CH3, CH2, MgCl. Then what will happen? Alkyl group is connecting, taking electrons, CH2 connecting here. Double bond is breaking and oxygen is taking electrons in this way. Then you can see that the first product that you will obtain is ONGCl. And we are adding H plus H2. We are adding H plus H2. What will happen? OH is leaving with this MgCl and hydrogen is connecting. Then we can see that CH3, COH, H, CH2, CH2. Byproduct is MgClOH. X can be bromine, chlorine, iodine, anything. Chlorine, bromine, iodine. X can be chlorine, bromine, iodine. Mg plus OH minus also correct. Doesn't matter. It's okay. Not but that much of a big deal. Right, okay. Shall we go to the third one? Number 3. We have acetone, CH3, C double bond O CH3. Right? Phenyl magnesium halide or else aryl magnesium halide. So what will happen? So nothing different, right? Same as before. This is taking electrons and this group is connecting to the carbon. Bond is breaking. Oxygen is taking this one, right? Same thing. CH3, OMgCl, CH3, phenyl group is connected here. Then when we add water molecule, hydrolysis reaction, H3O plus is added. Then what will happen? CH3, COH, CH3, and here we have the phenyl. Right. So hereafter, I won't write down the byproduct because byproduct is not that much important. From the next reaction onwards, I'm not going to put these arrows also. Okay. Now you can have the idea about what happens. So therefore, now you should be able to directly get the products. Huh? Now you can do it. No, it's not compulsory. Remember, if they ask reaction mechanism, right? Now in the examination, they will ask you write down the reaction mechanism for the reaction between aldehyde with this Grignard region. Then use those arrows and show delta plus, delta minus like that. Now these are some kind of normal reactions we are writing. Okay. So I wrote these reaction, made these arrows and everything in order to understand, in order to better understand. Okay. Number 4, fourth one. Now they have exchanged them. right? They have put the aldehyde ketone here and the Grignard region here. The same thing, right? We don't have to worry about that one. From anything we can start, reaction is always same, right? So what will happen? You can directly take this one. MgCl is connecting to oxygen. The CH3, CH2 is connecting to carbon. Then CH3, C, CH2, CH3. And here we have O MgCl. Right? Now you have some kind of a practice. Huh? Now you have some kind of experiences. Nothing to worry. H plus H2O, what will happen? Directly this is converting into OH. CH3, OH, HCH2, CH3. Etc. Right? Quickly. If you have any doubts, put your doubts in the chat box. Number 5, quickly. Huh? You have to write down these reactions quickly with me. Grignard region is reacting with methanol. MgBr is connecting to oxygen, phenyl ring is connecting to carbon. Then we are adding H3O plus. What will happen? It's producing this kind of a alcohol. Tell me, is this difficult? Huh? Is this difficult for you? No, right? Easy. So far, no, sir. Shall I raise third one? Yeah. So every Wednesday hereafter, we are going to discuss these kind of reactions, and we are going to practice these reactions. Huh? What about if we have magnesium halide like this CH3 MgI, and we are adding yes, acetone CH3, C double bond O CH3, right? So same thing, right? So in the Grignard region, we can separate this MgI here, and this is the alkyl group, right? So the alkyl group is connecting to this carbon. But be careful, this carbon is connecting to this one. Then we can consider C, right? Let me put this CH3 group down here, and I'll connect that one here. So can we do like that? Yeah, we can do. Doesn't matter, because we are not writing isomers here, right? You can separate anywhere. Anywhere means suitable area, right? OMGI. H3O plus is added. CH3. OH. Can you understand? So always when a something is added to the initial compound, it's a nucleophile. No, it's not nucleophile when it is added always some kind of a thing when it is added nucleophile. It can be the electrophile also, right? Let's discuss electrophilic reactions also later, not only the nucleophiles. Yeah, Lakshmi, we can write down in that way also. Always the product is an alcohol. Yes, you're correct. Always the product is an alcohol. Right, students, shall I erase number 4 and number 5? Shall I erase number 4 and 5? Are we done with that? Okay, quickly, yeah. You have to write down quickly. Number 7, let's try to go for the reverse. Reverse. We are going to the reverse. Number 8. Look at the 8th one. So let's try to obtain these reactants. Try to obtain the reactants. Number 7, 8, 9. Raise your hand who completed 7, 8, 9. Raise your hand who completed 7, 8, 9. Okay, good, very good. So Hana, we don't have to write down the final byproduct. We don't have to write down the byproduct. So writing a major product is enough. Huh? Mainly in conversions, actually, they're not expecting us to write down byproduct. Writing major product is enough. Right, okay. So how do we name the product of the fifth option? Is it Benzyl methanol. Fifth one, what is the fifth one we discuss? So the fifth one is this one, right? Yeah, we can consider this is benzyl methanol. Yes, correct. That is the name. Benzyl methanol, because one carbon atom, benzene ring is there, so therefore benzyl methanol is correct. Now look at the seventh one. Students, we have to go for the reverse. Since we have added the Grignard region MgCl, in here we have alkyl group CH3CH2. Definitely the previous reactant should be OMgCl, right? No doubt about it. And look at the CH2CH3. So this CH2CH3 group is the one came from the Grignard region. We had CH3CH2, right? This is the CH2CH3 group which came from the Grignard region, and we know that this is the MgCl, the other part of the Grignard region. Then forget about these two and just think about the remaining compound. Carbon is there connected to oxygen and two alkyl groups. Then the initial region we had is acetone, CH3C double bond CH, isn't it? Right? When you forget about these two groups which came from the Grignard region, right? Then the remaining things are carbon connected to oxygen. That carbon is connected to two methyl groups from both sides. So therefore the initial reactant was. So raise your hand who understood that reverse process. Please raise your hand. Is that difficult? Shape, ne? All right. Okay, good. Right. Then go for the number 8. In the 8th one, MgI, ne? MgI is added and the phenyl ring is added. Then here, first of all, we can consider this is OMgI. This is CH3. Here we have the phenyl ring, right? CH3, phenyl ring is there. And students, we know that the Grignard region we have added is phenyl magnesium iodide, right? Phenyl magnesium iodide. Let me consider this is the benzene ring came from the Grignard region, and this is the MgI group came from the Grignard region. Then forget about these two and consider the remaining things. Then we have benzene, C double bond CH3. Neither. In this way. Number 8. So you should be able to think the reverse also. Or the reverse right? Look at the 9th one. In the 9th one, we can say that anyhow, this one should be CH3, CH, OMGBr, CH2, CH2, CH3, and students, this is very easy. This is very easy. We can see that the MGBr definitely came from the Grignard region, so we can see that one. So propyl group CH2, CH2, CH3, a propyl group came here. Then what are the remaining things? Remaining things CH3, carbon, hydrogen is connected to that carbon, and carbonyl group C double bond 2. That means we had ethanol. Right? Here's the number 9. Raise your hand who got the correct answers for number 7, 8, 9. All three correctly. Raise your hand who got the answers for 7, 8, 9 correctly. Okay, very good. There are so many. AMI. Okay, then without wasting time, let me go for the other examples also. Number 10. Don't think that we are repeating the same thing. This repeating same thing is very important when you go for the examination. You will understand. Okay. So therefore, be humble and do these reactions with me. Okay. Maybe you are talented. I know that. Anyway, you do these things with me, right? Number 10. So here we are adding H3O plus. Two butanol. 11th one. Ethanol CH3 CH2OH. Here number 13, directly we are going to add number 1, number 2. We are adding Grignard reagent CH3 NgCl. Now we are going to add H3O plus. Now students, you should be able to get the product directly. Can you understand me? So likewise, I told in conversions, we have to put number 1 and number 2 and directly we have to obtain the alcohol. That is the method. Try it quickly. Number 10, 11, 12, 30. Try them quickly. Students, number 10 should be like this. We have added ketone, right? Look at the ketone carbonyl group is this one. So carbon, this CH3 group, here you can see in this way, and CH2CH3, CH2CH3. Then here we have to identify what is the Grignard region. Can you understand? So this is a ketone. Then ketone is reacting with the Grignard region. So where is the Grignard region? So we can write down here. Intermediate is like this. OMgCl, let me write down Cl. CH2CH3, phenyl ring. So all these three groups are here can be seen. Are then phenyl magnesium chloride is the Grignard region, MgCl. So can't we use MgBr, MgI? Yeah, that is your wish. Anything you wish. Number 11. Easy. Number 11. So here also we have to identify what is the Grignard region we have to see how easy these things are. OMgBr. Phenyl group. Two phenyl groups are there. One. Then the Grignard region is CH3MgBr. CH3MgBr is the Grignard region. Number 12. Number 12 is easy. CH3, CH2, OMgCl. So what is the group that they have added? Methanol, formaldehyde. That means one carbon, two hydrogen. So when you spread the bonds in this way, you can clearly see that carbon, two hydrogens in this way, and this is the carbonyl group. Then CH3MgCl is the Grignard region that we have added initially. See how easy these things are. Raise your hand who got the answers correctly for number 10, 11, 12. Raise your hand who got the answers correctly for number 10, 11, 12. Right, okay. Don't worry about the naming of these compounds. Don't worry about the naming. Some of the organic compounds nomenclature is not related to our syllabus. That is very complicated, some of them. Nothing to worry. No need. Byproduct is not necessary, Rafa. Yeah, instead of MgCl, we can use MgBr also. No, there is no such compulsory thing to use only MgCl. Remember, students, when we are adding a Grignard region, MgCl, MgBr, MgI, chlorine, bromine, iodine. These three halogens are okay, right? You can use as well. So why you are not using fluorine? Fluorine is not using because fluorine is highly electronegative, right? So therefore, the Grignard region is not stable with fluorine. Got it? So now, students, check whether you can obtain the product, final product directly without going for this intermediate. Now we know that when we add Grignard region, this is the intermediate. We are going to do the hydrolysis for that intermediate and then only obtaining the alcohol. Can you obtain that alcohol directly? What do you say? Students, that's very easy. Okay? You know that this CH3 group should be connected to that carbon, right? Hydrogen here. Then what should happen with this oxygen? That is connected to OH. That's all. So I think you could have taught this one at the beginning. Why we are learning these things? I think students, you have to understand what exactly happening inside. In case they have asked a reaction mechanism for aldehyde ketone with Grignard region. If they ask what are the intermediate, then they ask when you do the hydrolysis for the intermediate, what is the final product? So likewise, if they separated and ask, you should be able to answer for those questions also. So first of all, I taught you the difficult part. What's exactly happening? Now this is very easy. Neither. What happened? Alkyl group came from the Grignard region connected to the carbonyl carbon. Carbonyl carbon, carbon oxygen double bond is broken and directly converted into carbon OH bond. That means alcohol. So is it always OH? Always OH. Nothing to worry. It's always OH. Always by reaction, from this aldehyde ketone and Grignard region, we are obtaining an alcohol. Understand? Why I have categorized this one under carbon increasing reaction? Look at the beginning, how many carbons were there? 2 carbons. Now in the final product, 1, 2, 3, there are 3 carbons. We have increased the carbon atoms in that compound. Therefore, this is categorized under carbon increasing reactions. Got it? Right. Number 14. Now you should be able to write down the direct products. Huh? I'm going to write down number 1 and number 2. Direct products, right? If you have any doubts, put your doubts in the chat box. Quickly write down the products. Students, if I have time this Saturday, I will upload to 2011 isomer question with explanations. If I have time, within next few weeks, definitely I will upload 2 or 3 isomer past paper examination question explanations. Okay. Term test time, right? So you have to get ready for your term test also. Ne? So if they ask for the reactions of aldehyde ketones with Grignard region, should we write only the first step in the reaction with H2 plus also? Pranali, they won't ask those kind of questions. If they ask Grignard region, the reaction with Grignard region, then you have to write down only the first step. but they won't ask. Don't think that in the structured essay paper they are giving some kind of single step reactions like this. Otherwise, in the essay paper and everything, you can't expect these kind of things. Huh? Maybe Baba part. Number 14. So we can say that alkyl group is connecting to that carbonyl group, COM. We can just write down this is OH, CH2, CH3. Alkyl group is connected to this carbon atom, and that carbonyl group converted to OH. That's what. Number 15. Number 16, how look like that? Benzyl methanol that you asked previously. What about this CH3, CH2? Definitely this is going to convert into OH. And what is the alkyl group came from the Grignard region? Students, always you have to put your eye on the alkyl group in the Grignard region. Alkyl group. Again, magnesium halide you have to forget that magnesium halide and put your eye on alkyl group. CH2, CH2. That's all. Here also same thing. So here we have a bulky alkyl. In this way. Raise your hand who got the answers correctly for this part. Very easy. Okay, very good. Huh? Very good. Okay, we are not done yet. Okay, we have to do a few more reactions. So why this much for one particular reaction? Then plus you have to understand how important this reaction is. Huh? If I'm practicing this reaction this much of times, then you have to understand how important that reaction is, right? When you're doing past papers, you will realize what I'm saying. Number 19. Number 19, let's go for the reverse directly. What do you say? Here they have given the final product, alcohol. You have to obtain the aldehyde or ketone that we have to use initially. Number 20. Phenyl magnesium bromide. H3O plus. See, that's why I told you, right? So when you are practicing these organic reactions, the benzene ring will be distorted, right? What is the benzene ring? සමහරලාට මේ කෑලි නෑ. හරි. Now look at this one. එහෙම තමයි හිටියේ, right? Look at this one. So writing benzene again and again is such a pain, right? What do you say? Instead of benzene, what we can write down? Instead of this phenyl ring, what we can write down instead of this one? C6H5, C6H5 in this way. C6H6, if you put C6H6, that is wrong. That is completely benzene. This is not benzene, this is phenyl. Phenyl ring. Okay, go for the reverse products. 21. Okay, I'm going to discuss number 19 and 20. So, students, you can see that this is the Grignard region, CH3, CH2. So, you can see that the group came from the Grignard region, and the others are remaining in that ketone, CH3, C double bond O, CH3. That's all. Number 20, you can see that this is the Grignard region. Phenyl ring came from the Grignard region. Then the remaining things are an aldehyde, CH3, CH2, carbon, hydrogen, double bond O. Right? Quickly do the last two also, 21, 22. How they ask questions in the examination in this part. Organic conversions. In the isomer question, finally they're asking single step reactions. So these reactions will be important in those kind of questions. So is it okay if you also write the byproduct when writing the reaction in one step? Yeah. So you can write down the byproduct, but here the byproduct is not compulsory, right? Only. Yes, Rafa, sometimes you will get these things in MCQs also, right? In MCQs also, you will be tested using these reactions. So what about 21? So in 21, we can say that here, this is the alkyl group. Ne? This alkyl group can be seen in here also. Then CH3, CH3. This is the remaining part. So the remaining part is carbon, two hydrogens, oxygen, methanol, formaldehyde. 22. This ketone, CH3 group, carbon here. Hydrogen is also this one. Then you can see that this is the Grignard region. This part CH3, CH3, H, MgCl. Okay, right? Last three. Last three. Shall I erase 19, 20, 21? 23, last one, 25. 23, we can see that methyl group here, two methyl groups are here. Then the remaining part is the Grignard region, CH3, CH2, CH2, MgCl. And here we can see this is the benzene ring. Hydrogen. This is the part came from the Grignard region, right? CH3, CH2. Let me take here this time MgBr. Got it? And can you see that this is the ketone CH2 phenyl ring? So you can take this CH2 phenyl ring, and benzene ring is there. This is the benzene ring. Then this is the remaining part. This remaining part came from where? The Grignard region. So therefore, phenyl CH2. Let me take MgI in this way. So you should be able to go for the reverse as well. No? You should be able to go for the reverse as well. Right, okay, students. So this is the first reaction that we have discussed, right? Aldehyde and ketone with Grignard reagent. So can you understand this reaction? Do you have any doubts in here? Please raise your hand who understood the reactions that we discussed here. Okay. Yes, sir. Kavisha, you can write down in this way also. MGI. That's awesome. Okay. So carbon increase in reactions number one is done. Aldehyde and ketones, aldehyde or ketones with Grignard. Now we are going to learn about the special conversion reaction number one, right? So write down the topic, special conversion reaction number one. So don't worry, we shuffle and write down, okay? We are not going to discuss all the carbon increasing reactions directly, all the special conversion reactions directly. We shuffle and discuss, okay? One by one. There is a flow actually, you will understand that. Special conversion reactions. Number one. What is it? Preparation of Grignard region. Already we discussed this one in the theory class, but doesn't matter because we have to discuss about the reactions now. Therefore, I'm going to revise this one. Preparation of Grignard region. If you don't know what is Grignard region, here is the chance to learn it. Preparation of Grignard region. Special conversion reaction number one that we are learning is preparation of Grignard region. Students, remember how we can prepare a Grignard region and what is a Grignard region. Students, when we take alkyl halide like RCl, let me take RX. So X can be chlorine, bromine, iodine, like any alkyl halide in this way, RX. Okay, and we are going to add magnesium dry ether, magnesium metal with dry ether. Why we are adding dry ether with the magnesium? Remember, students, magnesium is actually reacting with the atmospheric gases. Magnesium is reacting with oxygen. In inorganic chemistry, you learn that to produce magnesium oxide easily. Magnesium is reacting with nitrogen to produce magnesium nitride Mg thrice and twice. Magnesium is not reacting with cold water. Magnesium is only reacting with hot water. So therefore, I'm not going to discuss the reaction with the medium, but I'm going to discuss the reaction with that atmospheric gases like oxygen. So when magnesium is exposed to air, definitely it is forming these two oxides and nitride. In order to prevent that reaction, we put dry ether. In order to protect magnesium metal, we want to do the reaction with magnesium and the alkyl halide, right? So therefore, we have to prevent that magnesium metal. So in order to prevent that magnesium metal, we add their dry. Then students, what will happen? It's producing a compound like R. Magnesium is coming to the in between R and X and producing alkyl magnesium halide. What is this? Alkyl magnesium halide. This alkyl magnesium halide is known as Grignard region. Actually, the Grignard means the scientist name. Grignard region. Can you understand? So this is what meant by Grignard region. This Grignard region is very important in order to derive many organic compounds, right? Very, very important. So some of the reactions are not existing without this alkyl magnesium halide. Sorry, Grignard region. That is very, very important. Okay. So let me consider a few examples here with you. Number one, this is very easy. CH3Cl. We are adding magnesium dry. So do we need to mention this dry ether? Is it compulsory? Yes. Definitely we have to mention it. CH3MgCl. Here, one of the Grignard regions. Number two, CH3CH2Br, magnesium dry ether. Number three, let me consider tertiary alkyl halide like this. In this way. So all of them are Grignard regions. Commonly, we can say that Grignard regions. Okay. Quickly write up. I want to put here some other examples. Quickly write up. The reason that magnesium is not reacting with dry ether. So ethers, what do you know about ethers? Ethers means oxygen is centralized atom and surrounded by alkyl groups. So therefore, ethers actually considered as weakly polar, or else we can consider non-polar compounds. So these non-polar compounds is not reacting with this kind of magnesium, right? So you have learned about a term like this, like dissolves like polar compounds are dissolving polar solvents and non-polar compounds are dissolving non-polar solvents. So likewise, here also, dry ether is actually a good medium to prevent magnesium because it is not reacting with magnesium. The reason is ethers are non-polar, or else we can tell weakly polar. So we learn this kind of a same thing like this in alkanes also. Paraffin, right? Alkane series is known as actually the paraffin series. Paraffin wax. We are using that paraffin wax in order to prevent sodium like highly reactive metals, right? Because they are not reacting, they are not participating for the reactions of these metals. So it prevents the reactions since they are weakly polar or non-polar. As I know, there is no method to produce Grignard region except this method. As I know, we have to search it, right? Rafa? Right. Quickly write down a few other examples. Right, okay. Are we done? Yes. Right. Students, today we discuss about two reactions. Shall we do some kind of a mix exercise using these two? Now we learn two reactions, and let's do kind of a mix exercise using this. CH3, CH2, Cl. Write down the region that we have to add on the arrow. Number one, what is the region we have to add? Magnesium dry ether. And here we are adding aldehyde. What is it? CH3, CH2. This is came from the Grignard region. MgCl also came from the Grignard region. Then the aldehyde we are adding is H, C double bond O. And here we can add H3O plus. Second one, magnesium dry ether and forming the Grignard region. CH3, C double bond OH is the aldehyde we are adding. And H3O plus. Okay. Yeah. Now okay, Asma. Right. So that's easy, right? We have added magnesium dry ether, then produced magnesium chloride. Now look at this one, CH3, CH2. CH3, CH2 came from this Grignard region. MgCl came from the Grignard region. Then here we have oxygen. Oxygen, carbon, and it is surrounded with two hydrogens. Methanol. Number three, We're adding magnesium dry ether and producing Grignard region CH3, CH2 MgBr, and we're adding keto. Adding H3O plus is giving the alcohol that OMGBr group is converting into OH. Can you understand? That's very easy. Quickly complete this. Right, okay? Are we done? Number 4. Quickly do this. So the fourth one can be completed like this. CH3, CH in the Cl. Like this, and H2O plus is added. So therefore CH3, OH, H. Right? So this is the fourth one. Because these things are very easy. Yeah? Number 5. In the number 5, they haven't given the first reactant, but it's okay. Let's see. That means we have to find out the Grignard tree. Right? The Grignard region should be CH3 MgBr. It can be MgBr, MgCl, MgI, anything. Huh? This is CH3Br, methyl bromide. Number 6. In the sixth one, you can see that diol. Diol means actually 2 OH groups are produced. That means we can consider CH2, MgBr, CH2, MgBr. CH2 OMGBr, right? OMGBr. Now, students, we can consider here magnesium bromide, MgBr, MgBr. We have added methanol in this way. CH3, sorry, HC double bond H, methanol. The specialty of this reaction is this methanol is connected to 2 positions of the benzene, right? This one and this one. And here, this is dihalide. Br here and Br here. This is interesting. Eh? We haven't seen this kind of a region before in the previous examples we discussed. So raise your hand who got the answers correctly for the sixth one. I want to know that one. Raise your hand who got the answers for sixth one correctly. Okay, good, good. Right. Students, I need a small help from you. So today is the day 1 of our organic reactions. Soon after the class, please send a small feedback about the session. Is it worth, negative or positive, anything, right? It doesn't matter for me. Anything you want to share with me, especially the new students. I think some of you haven't seen me before. So therefore, anything that you want to share, you can share that one in WhatsApp. Okay. Please send me a feedback about the first session that we conducted today. Okay. Right. Are we done with these 3, 4, 5, 6 example conversions? Right. Right. Okay, students. Now the time is up. Now time is 11, but we are not done yet. I'm going to give you a homework. So after every class, I'm planning to give you some small conversions. That means conversion of the day. Likewise, small conversions are given. So you have to do those conversions and send me the answers. Right? I'll upload the answers before the next class, and you can check your answers. Okay. So shall I erase these three? And shall I put the conversions? All two small conversions. Actually, you can do them now. Are we done with this one? Do you need some time to copy down this? Anyone? Done. Okay, so this is a small homework. Sometimes this is 2-3 minutes. You can send the answers if you want soon after the class. Do this one as a home, right? So next Wednesday also we are meeting in the same time with new reactions. In the theory class also we are continuing the theory. So therefore parallelly, let's do like this. Okay. Right. So before you leave, do you have any doubts, students? Anything you want to ask? Anything? Any doubts? If we do like this continuously, I mean the work you give can be complete organic well. No, this is only a part of organic. Huh? You follow your theory class properly, you do questions properly, and you have to do past paper questions, everything properly, right? Every part. Then only the organic means a package, complete package, right? At the beginning, I told you isomers are there, nomenclature is there, mechanisms are there, conversions are there, theories are there. So this complete package, when you complete this complete package only, you will get that 20 marks. You understand? So I'm discussing here the two most important parts of this organic. One is organic reactions. With this one parallel, I'm going to discuss isomers also. I will inform that one. Probably I won't discuss that on live sessions. I will upload the recordings. So that's what I have planned. But there are many more things. Okay, everything is in your hand. Do the past papers, do the questions. Everything will be okay. But I'm very sure that until your exam, before your examination, we are going to cover all the organic reactions with conversions. All the past paper isomer questions from 2011 to 2023. For that, I guarantee. No need to worry. Okay. And my theory students, you know that what is the plan we are going. In theory class, we discuss our theories as usual. Okay. Don't worry, follow these organic reactions. You can do that. This is not full organic. That's what you have to understand. Right. Okay. Then let's meet on the next class. Until then, bye bye. Have fun. Good night for all of you. God bless you.